All right, so we are moving on to Unit 4. Now, I'm going to tell you some good news. I'll tell you some bad news. The good news is short term. There's no homework tonight. Yay. Okay. The not quite so good news is as we move into this new unit, this first lesson is going to be a little overwhelming because there's a lot of big words. But these big words are masking some fairly simple operations, okay? Like the term multiplication when you were 6 probably sounded really intimidating, and then you learned that 2 times 2 is 4. You're like, oh, that's not so bad, okay? I think that's going to be kind of the vibe here. So our goal for today is just to kind of get the lay of the land here. Let's see what's going on. Tomorrow, we're going to do some practice and evaluation and make sure we know what we're doing. So this is where logic gets really practical. Because as you guys have asked and you guys have observed, no one talks in categorical statements, right? Nobody walks up to you and says, all squares are four-sided shapes. No circles are squares. Therefore, like no one talks like that. So how do we use logic? Well, we use logic by taking the things people say and putting them in standard form. Bean? Okay. So here's a syllogism. All non-believers are unsaved people. No believers are non-Christians. Therefore, all Christians are saved people. Now, how many terms are in that syllogism? No, look again. How many terms are up there? Non-believers, unsaved people, believers, non-Christians, Christians, saved people. That's 6 different terms. We have 6 terms up there. How many terms do categorical syllogisms have? 3. So as it currently stands, you don't know how to evaluate that argument. You might be able to intuitively figure it out, but you couldn't prove to anyone whether that's valid or invalid. But that's how people talk in real life. They don't talk in categorical statements. So what we're going to do today is learn how to translate normal sentences like these into categorical statements. And we're going to do it by talking about 3 big words. If I put it up on the board and it's underlined in bold, that's what you need to write down. You don't have to worry about writing anything else down. Just write down what's underlined and in bold. So the first thing we're going to do today is learn how to translate arguments using what we call immediate inferences. So here's your definition. Immediate inferences are statements that can be inferred from another statement. Now, inferred just means you can draw the conclusion from another statement that this other statement is also true. So for example, if I prove to you that all trees are tall, then you can infer that it must also be that some trees are tall. What do we call that?
Subimplication.
Subimplication or implication, right? It's implication. If the universal is true, the particular of the same quality must also be true. So you already kind of know how to do this. So this is what we call drawing inferences. Now, that's implication. Thanks to logical equivalence, we can also infer this. If it was true that no trees are tall things, so let's say the S here stands for trees and P stands for tall things. If it were true that no trees are tall things, it would also have to be true that no tall things are trees, right?
Yes.
That would have to be true. And if it was true that some snakes are reptiles, it would also have to be true that some reptiles are snakes, right?
Yes.
So we can know that from logical equivalence. Now note, what 2 types of statements are up here? That's an E and that's an I. So we're going to talk about a relationship called converse. Yes, like the shoe. So, Theo?
Wait, you can only do like that on like I's and E's, right? Because
Right.
some
Yes.
are not.
Yes.
It's like genus and species.
Right. So as Vale is pointing out, the converse of a statement, you can only do this for E's and I's. So think of it this way. If I said to you, there we go, went around the back of this thing. If I said to you, all trees are tall things, and I tried to make the converse of this statement, or if I tried to do logical equivalence like on the last screen, and I said, all tall things are trees, is that true?
No.
No, it's not true. So when we talk about the converse, which is a statement that reverses the subject and the predicate, right? Flips them around. That's all the converse is. You take a statement, you take an E or an I, and you flip the subject and the predicate. That's it. That only works for E and I statements. So in very big letters, make sure you remember this. Converses are only valid for E and I statements. You cannot take the converse of an A. You cannot take the converse of an O. You can only do this for E and I. So like we said, all trees are tall things does not imply that all tall things are trees. Some people are not pet owners does not imply that some pet owners are not people, right? There's no alligator walking around with a pet poodle, at least not for very long, right? So that's not how this works. Guys, my alligator poodle joke killed in third period. I'm a little disappointed I didn't get a better laugh. I know you guys are writing notes. Thank you. Too late, Sally. You ruined it. All right, we're moving on. Moving on. All right. So how do we feel about converse? E's and I's switch the subject and the predicate. Okay? Feel good?
Sir.
All right, let's move on to the next one. Another type of immediate inference is called an obverse. Okay? An obverse is a statement of the opposite quality with a negated predicate. Okay? An opposite quality with a negated predicate. And again, those are some big words, but it's not that complicated, I hope you'll see. After all, how many qualities are there? Two. And so if it's one, it's just make it the other. If it's affirmative, make it negative. If it's negative, make it affirmative. There's not like 31 flavors like a Baskin Robbins. It's two. It's affirmative or negative. Okay? So let's look at what it means to take the obverse of a statement. So all S is P. What is the quality of that statement? Bean? No, quality, not quantity. Quality. Weaver? It's affirmative. So what's the opposite quality of affirmative? Negative. So we would make that no S is P. And then all we have to do to negate the predicate is put the word non in front of it. So no S is non-P. So the obverse of all S is P is no S is non-P. Okay? The obverse of all S is P is no S is non-P. So how about this? Look at it like this. All apples are fruits. Are fruit. All apples are fruit. Okay? So let's switch the opposite quality. No apples are fruit. And now let's negate the predicate. No apples are non-fruit. Is it true that all apples are fruit?
Yes.
Is it true that no apples are non-fruit?
Yes.
Also true. That's the obverse of a statement. You switch the quality and you change the predicate to its complement. And as I say the word complement, you might think, well, what's a complement? Well, I got you covered. Here it is. The complement of a term is the set of all terms not included in the given term. So when I talk about fruit, if I said P equals fruit, okay, P equals fruit, what is the extension of the term fruit? What is included under the term fruit, Sally?
Banana.
Yeah, all fruit, right? Every fruit in existence. What is the extension of non-fruit?
Nothing.
No,
Oh.
everything besides fruit. And not just food. Asteroids, meteoroids, water, oxygen, gold, books, desks, chairs, cars, angels, everything, right? Everything besides fruit would be under non-fruit. That's what's called a complement. Okay, Reed, you had a question?
It kind of seemed like the one with like the Muslim question on the test. It kind of seemed like I thought. Because I remember I came up and asked you, and it was like I think it might have said something kind of sort of like that.
Like the non.
Yeah, it was like all. It was like all around TikTok, whatever it is, are Muslim or not Muslims or something. And
I'm not quite sure I know what you're referring to, so maybe we could just talk. You have a question about this?
no, it just kind of seemed like the question in the test yesterday. I was kind of phrasing.
Possibly it was. Yeah, Sally.
I've been learning about that whole season, or not whole season. Whole year.
Sally's binging a Netflix show out here. All right, go ahead.
All like semester or whatever. Because all S is not P is basically the same thing as no S is.
Correct.
That's what I'm thinking.
Why
Yeah.
have you been worrying?
So but what you've been thinking, Sally, and again, I think what that hopefully should encourage you is that logic is somewhat intuitive, because logic, as we're studying it, is just trying to understand how God made the world. Like the reason that you kind of grasp that without me ever saying obverse or anything like that is because you have a mind made by God. You're made in God's image. And so you kind of were able to feel your way to that. Like, yeah, I mean, it's true that all apples are fruit. It has to be true that no fruit or no apples are not fruit, right? Like that has to be the same thing. And yes, you're right. Yes.
So if you had I statement like some S is P, then would it be like the obverse and the complement? Like it would be some S is not is
Well,
not
if you
not-
had, okay, if you started off with some S is P, okay, I need to make it the opposite quality. So now we have some S is not P, and then I need to make the predicate its complement, and I would say some S, and I have to put this up on the board so you have to write this down, is not non-P. Okay, how about this? Some, I don't know why I'm thinking apples and fruit, but some apples are fruit. Okay, some apples are not fruit. Some apples are not non-fruit.
This sounds kind of fun.
It sounds funny. It sounds really awkward. It'd be much easier to say some apples are fruit. But if I say some apples are not non-fruit and some apples are fruit, I'm saying the same thing. The truth value of both of those is the same. Those are both true. Yes.
Just like true negatives, just positive.
Yeah, it really is. I use that example in third period. Yeah, it's like you multiply a negative by a negative, you get a positive. So if I say not non, I am multiplying and they cancel themselves out. Now, the difference, unlike the converse, the obverse of a statement, the obverse is a statement, is valid for all four kinds of statements. So as we just demonstrated, you can do an obverse for all four types. So you don't have to write these down. You can if you want. But just to show you what this would look like, all S is P. The obverse of all S is P is no S is non-P. So all mosquitoes are bloodsuckers. The obverse would be no mosquitoes are non-bloodsuckers. Take every mosquito in the universe, not a single one of them is a non-bloodsucker. In other words, they're all bloodsuckers. Okay, how about no S is P? Well, reverse, opposite quality, negate the predicate. No S is P, all S is non-P. So no ladybugs are bloodsuckers, all ladybugs are non-bloodsuckers. Some S is P, some S is not non-P. Some leeches are bloodsuckers, some leeches are not non-bloodsuckers. Some S is not P, some S is non-P. Some moths are not bloodsuckers, some moths are non-bloodsuckers, okay? So you can take the obverse. Now, if we're thinking carefully here, converse only works for E and I. Obverse works for all four. So which one do you think the last one applies to? A and O. And the third one, I will admit, is the one that's going to feel the most like, whoa. Okay, so I feel you. It's called the contrapositive. Here's your definition. The contrapositive of a statement is a statement that reverses and negates the subject and the predicate of the original statement. So it reverses, it flips them. So all S is P becomes all P is S, and it negates both of them. All S is P becomes all non-P is non. I mean, so it sounds very bulky. Now, I'm going to give you a step-by-step of how this would look. And again, we're not going to do this for homework tonight, but we will do some of these together tomorrow. So don't be intimidated today. Okay, I'm not expecting you to have this down cold. I am Not expecting that at all. So here's what you could do. And I'm going to show you how this would work. If I told you to take the contrapositive of an A, you would take the obverse of that statement, then the converse of that statement, then the obverse of that statement. Now, if I told you, I gave you something like this, like 3 squared plus 3 times 9 with like the 4 times 5 in here, that would look really intimidating to those who haven't had math, but thanks to order of operations, like you now know how to work that problem, right? Like you know which thing comes first and how to do that. And this will become like that. This process will become like that, where you're like, okay, order of operations, I know obverse, converse, obverse, I know how to do this. Okay, so I don't expect you to be there right now, but you will get there. But this is where we're headed. So let's demonstrate. So here's our original statement. All S is P. And we're told to take the obverse of that statement. So that means opposite quality, negate the predicate, right? So all S is P becomes no S is non-P. Then we're told to take the converse of that statement. Okay, so that's what it looked like in words, okay? Followed by the converse of that statement. So no S is non-P becomes no non-P is S, right? So we've taken the obverse of all S is P, no S is non-P, and now we've taken the converse of no S is non-P. What do you do when you take the converse of a statement? What do you do when you take the converse of a statement? You just switch the subject and the predicate, right? Switch the subject and the predicate. Okay? So all we did when we did step 2 is we flipped the subject and the predicate. No S is non-P becomes no non-P is S, and then we're told, hold on one second, Dale. Then we're told to take the obverse of that statement. So if I take the obverse of something, what do? I switch the quality, right? Opposite quality, and negate the predicate. So what would that sound like? What's the opposite quality of no non-P is S? It would be what? Now just switch the quality. No non-P is S becomes all non-P is S. But when I do the obverse, I have to switch the quality and then negate the predicate. So no non-P is S becomes all non-P is non-S. Okay, all non-P is non-S. So here's what it would sound like. We started with all mosquitoes are bloodsuckers. We took the obverse, and that gave us no mosquitoes are non-bloodsuckers. We took the converse, which is no non-bloodsuckers are mosquitoes, and then the obverse, all non-bloodsuckers are non-mosquitoes. You take everything in the universe that doesn't suck blood, how many of them are mosquitoes? None. Okay? So this is the same thing. It's the same thing. Dale.
2 things. First of all, on this slide, what are we supposed to write down?
The stuff that's underlined.
You can write down the stuff that's underlined, or you can write down none of it. It's in your book as well. It's totally up to you.
And also, wouldn't it be like a you statement, like all non-bloodsuckers are not mosquitoes?
A you statement?
I made it up.
A you statement? I don't know what a you statement is.
All not. Is what
It's the
that
same
looks
thing
like.
as a universal negative.
Am I getting 2 questions right now or 1? I'm not sure if you're disagreeing or with her affirming her. What's a you statement, Bale?
Oh, it's like an all not.
It's where you.
Okay. Well, Bale, if you made it up, you got to tell me if it's a you statement. I'm not quite sure. But if you want to call it a you, go for it.
It looks like it because like all non-bloodsuckers are not non-mosquitoes.
Yeah, could be. Again, that's your thing. So I'm not going to say you're right or you're wrong. Sally?
Well, so I don't see the point of going to the options of that statement because it's just the same thing as all that stuff.
Well, the point is, we now have changed terms, and I'm gonna land this back. Remember that first syllogism where we had 6 terms and we didn't know how to evaluate it? Okay, if you notice how these 2 statements, which have the same truth value, we have now changed the terms from mosquitoes and bloodsuckers to non-bloodsuckers and non-mosquitoes. So if we can do this, we can get our syllogism that might have 4, 5, 6, 7 terms into a syllogism with 3 terms that we can now evaluate for validity. Okay, so that's the point of doing this, as I will show you in just a second. Anna? No. All right. So just like you already know, we already talked about this. contrapositives are only valid for A's and O's. Okay, contrapositives are only valid for A's and O's. So converses, E's and I's, contrapositives, A's and O's, obverses, all four. Bean?
If it goes from all mosquitoes are bloodsuckers to all non-bloodsuckers are non-mosquitoes. So if a non-bloodsucker is like a chair, and then non-mosquito is like a person, doesn't that mean if you use counterfeit, all chairs are people?
What?
No.
All non-people are not.
Why are you trying to figure this out?
You're just confusing.
All right, so almost there. Every statement has two equivalent immediate inferences. Now, I didn't underline the rest of the screen, but think about this. If you will write this down now, every time you see an all SSP and the question said, write the obverse of that, you would know all you need to do is plug the subject and predicate into this form. Okay? So my recommendation, but not requirement to you, and I will leave this up here for a couple of minutes, is that you would write down everything on this screen, because this will make your life immeasurably easier in the days ahead. So, every statement has two equivalent immediate inferences. So every A statement in the universe, you can have an obverse and a contrapositive. Every E, you can have an obverse and a converse. Every I, you can have an obverse and a converse. Every O, you can have an obverse and a contrapositive. Yes, and the contrapositive of some S is not P, is some non-P is not non-S, and that sounds really awkward and weird, but that's what it is. So look, if I said to you, some dogs are not reptiles, and I said, give me the contrapositive of that. Well, you could walk through all three of those steps, or you could just pull out this piece of paper that you've written down, and you could say, okay, hold on. Some non-reptiles are not non-dogs. Okay? And look, there it is. You didn't have to go through all three of those steps. You just wrote down, you plugged in your subject and predicate into this form. Okay? Some dogs are not reptiles. Some non-reptiles are not non-dogs. Yes?
On the third one, on some SSP, after the colon, it says some is not. No.
There you go. Okay. So again, I'm going to leave this up here. I'm going to write this down. If you like a challenge, you're like, no, I'm going to do this myself. From scratch, every single time. Go for it.
Who would do that?
No.
I don't know.
No.
I don't know. But you don't have to. That's the glory. That's the glory.
I keep writing SP instead of S.
Non-P. Jackson, write it down in your brain.
Right on your forehead.
Yeah.
Oh, Mr.
You'll totally be able to read that.
Hey, you can read with these.
Right.
Look, he's a fast writer now.
Whoa.
He never had.
He's insane.
What? Backward.
All right, I'm going to finish this lecture and I'm going to come back and leave this slide up. So don't freak out. Last slide. So we need these immediate inferences to translate arguments with complementary terms into standard form syllogisms. So our original syllogism was this: all non-believers are unsaved people. No believers are non-Christians, therefore all Christians are saved people. And we don't know how to evaluate that syllogism. But using immediate inferences, and we're not going to do this step by step, but using immediate inferences, we could come up with this. All saved people are believers. All believers are Christians. Therefore, all Christians are saved people. It's got three terms, so we can analyze it. Is it valid? Is the middle term distributed?
Yes.
Yes. Is there a distributed term in the conclusion?
Yes.
Which one?
The
Christian. Is it distributed in the minor premise?
No.
No. Okay, so it's invalid. It has the illicit minor. Okay, so we took that argument that we didn't know how to evaluate. We now did all that work, and we can evaluate and say invalid argument. Okay, so let me hit stop.